In this presentation, we're going to look at the normal distribution. So this is question 1B from the 2011 Business Statistics paper. A publishing house produces assembly manuals for kit cars. The number of manuals sold each year is known to be normally distributed with a mean of 500 and a standard deviation of 50. Immediately what we're going to do is pick out that piece of information there. Mu equals 500 and the standard deviation of 50, sigma is equal to 50. Okay. Now, what is the probability that the number of manuals sold will exceed 600, and what is the probability that the number of manuals sold will be less than 300? Let's do both of those first. So what we're interested in is X, and X is, capital X, is number of manuals sold. That's what X means from now on. Okay. The notation can be, in business statistics, can be quite a lot of it, so it's a good idea to have a clear idea all through. Number of manuals sold. And what we're interested in is sold. What we're interested in is what is the probability that the number of manuals will exceed 600. So we might write that mathematically like this: probability that the number sold will exceed 600. Okay, and that's what we're interested in. Now, first thing we do is we have X, which is small x, is equal to 600. And what we have to do first off is find the z-score for 600. How do you find the z-score? Well, there's a little formula in the back of your exam papers, or it should be somewhere in your tables or the back of your exam papers. And the formula looks like this. So what we're interested in is some value z, small z, and it is, I'll put a little cross there just to sort of emphasize it's small z, and it is equal to x, small x, minus mu all over sigma. Okay, so we have those three values there, so that's equal to 600 minus 500, that's mu up there, the mean, divided by the standard deviation 50, and that is equal to 2. So what does that mean? Just first off, that means what we're interested in here is the probability of x greater than or equal to 600. We can actually state this here. That's equal to the probability of z, that's a capital Z, greater than or equal to 2, because x equals 600 and z equal 2 are related by that formula there. Okay, so this is a very important formula going forward. Not so much a formula, an identity. That probability of x greater than or equal to 600 is equal to the probability of z being greater than or equal to 2. Let's just pause it there, and I'll reset the page. So we're told this, that the probability of z equal to 2 is, well, we know that this is relevant. Now, but how do we calculate this? Well, here we would use complementary cumulative normal tables. And if you're familiar with one example is Murdoch Barnes table 7. Okay, so that's the type of tables I'm going to use. I have a separate presentation around about how to work with these tables. So that's what we're going to use. And how do we use them? Just a quick reminder. We'll just actually write this again to 2 decimal places. So I'm actually just going to replace the 2 with 2.00. So that it has 2 decimal places there now. Okay. So what we're interested in is picking out the row and the column from the statistical tables. And so the tables is sort of set up like this, that we have rows at columns at so on. So let's say we have 0.00 here, 0.01, 0.02, and so on. And we have rows, for example, like this in the tables. And suppose we have, just to sort of pick numbers we're going to work with, 1.9, 2.0, and 2.1. So this cell here corresponds, will give us the probability that we're looking for, because it is equal to 2.0 plus 0.00 gives us what we're looking for, 2.00. Okay, that's the way these tables work. Just to give you a counter example, this cell here, that would be 1.9 plus 0.02. So that will give us the probability of Z being greater than 1.92 if you just add them together. So we're interested here in 2.0. And looking at the statistical tables, that is 0.02275. Yeah, so there's that is the answer we're looking for. 0.00, sorry, 2275. So that is the answer that we are looking for. And so that's the answer to the first question. I'm just going to go back to the previous slide here and confirm that is the answer. It's 2.27%. So the probability of x greater than or equal to 600 is equal to the probability of z greater than or equal to 2, and that is equal to 0.02275. So that's the answer to part 1. .2275. So what we're going to do now is calculate perform the second operation. What is the probability that the number of manuals sold will be less than 300? So let's just go to a new slide here. So what we're interested in is this probability of x being less than 300. Okay. Well, first off, what we're going to do here is find the z-score. And the z-score is for 300. That is equal to 300 minus 500 all over 50. Just a reminder, that's x, small x, minus mu all over sigma. And we get that is equal to 300 minus 500, that's minus 200 divided by 50. So that gives us minus 4. So probability of x less than 300 is equal to the probability of z being less than minus 4. Now, if you look at your statistical tables, you see that the z values only go from 0 to about 4. Okay? There's no negative values. So what we're going to do here is use the interval rule, or sorry, not the interval rule, the symmetry rule. And the symmetry rule is quite important in calculating. It's very important in calculating negative. When you're working with, it's very important in normal probability distribution questions. So the idea of the symmetry rule is essentially this: that the probability of z being less than minus a is equal to the probability of z being greater than plus a, where a is just some number like 1.96 or something like that. A is just like a number. So we can sort of say this. So essentially, just using this example, that means the probability that's equal to the probability of z being greater than plus 4. Okay. So that is what we're going to look up in the statistical tables here. The probability of z being greater than plus 4, because that is equal to the probability of z being less than 300. So I'm just going to clear the tables here, or clear the screen here a bit. No, actually, I'll go to the next slide. And so again, we're going to look at the statistical tables here, and we're going to look down the bottom. Now, you might notice that the numbers here are really, really small once you get down to the bottom. So again, we are looking at I'll leave plenty of room this time. So this is the rest of the tables. This is 0.0, let's say 3.9, 4. It's actually right down the bottom. I don't think there's any more there. So the answer we would get here is in this cell here. And what the answer is 0.00004032. So it's a really tiny probability. So that's the answer we're looking for. The probability, that is the probability of z being greater than or equal to 4. And that is equal to the probability of x being less than 300. So the answer there is 0.00032. Let's go back to the last slide. Yeah, so that's it there. Actually, I'll just I'll leave it the presentation there. That's good. So again, the answer to we've done the first two now. We've done this one, and we've done this one. I'll start a new presentation on the next for the rest of them now. So that ends this presentation.